Welcome back to another installment on inequalities by multiplication. So let's get started. The first problem, you're told if n is greater than -1 and it's less than 1, all of the following could be true except. So here's what you have to do, or what you can do when you are presented with a similar problem, is to work the answer choices and figure out under what circumstance or context does the expression fail. If it fails, then that is the answer. Here's what I'm saying. Let's choose choice E, okay, because it's the easiest of the expression. You can divide n on both sides, which would simplify this expression as n less than 1. We already know n is less than 1, so this is going to work. So that's not the right answer. Let's go to B, because that's again an easier option. So n squared is less than 2n. You can divide by n on both sides, which would leave n is less than 2. Now, if you haven't really worked the remainder of the choices, then you might be making a grave mistake thinking, well, n is less than 1, which means n cannot be equal to 1. But when it says n is less than 2, that means n can be 1, 0, -1, and so on. And n also is not, greater than, it's not less than -1. So this could be the answer. Inequality doesn't work that way. Okay, n, we don't know a precise value of n. Until we know that, we can't just pick one value or two value and substitute it into an expression and say, okay, we have satisfied the condition. It doesn't work that way, right? You're not looking for a value. What you're looking for otherwise is there a value that is captured by the range? Well, 0 is captured, right? And it doesn't have to be, didn't say it is all integers. It could be fraction, it could be plus 0.25, it could be -0.25, and so on. So n less than 2 includes 1, 0, -1. That's the way you should see it, not as a value that you can substitute and say 1 is not less than 2, so therefore that is incorrect. No, it doesn't work that way, right? So B is correct because it does capture the interval. Let's go to C, because that's another easy one. We have 16n squared minus 1 equals 0. So 16n squared equals 1, n squared equals 1 over 16. N equals plus or minus 1 over 4 or plus 0.25 and -0.25, which is captured by the interval. So C is not the right answer either. Okay, when I put a tick mark, I'm saying that the expression actually worked. That means it's not the correct answer. Okay, let's go to D. N minus 1 whole squared greater than n. To do this portion, you have to actually expand the expression, which is a minus b whole squared equals a squared plus b squared plus 2ab. So then that becomes n squared minus 2n plus 1 greater than n. To simplify the right side, you can simply add -n on both sides, which would make the whole expression greater than 0. Now, again, as I said, we don't know a precise value of n. What this expression is really telling us is, irrespective of what the value we put in from this range of -1 to 1, our value is always going to be greater than 1. You don't believe in me? Substitute n equals 0. We know 1 is greater than 0. You substitute plus 0.25, the answer is greater than 0. You substitute n equals -0.25, it's greater than 0. Irrespective of what you substitute within this range, the expression works. So that means this is correct as well, which leaves us with, by default, A is the correct answer. You don't have to do it. Unfortunately, if you started with A, then you would have already figured out it failed, okay? But you can also do it by elimination, where I started with the easier ones and then worked my way up. And then I would cancel 4 out of 5 choices, which leaves me with A as the correct answer. Okay, now let's go ahead and do the second problem. We have √8 over -x is less than 2, right? So again, we have to stick to our own logic, which means we have √8 over -x and is First, we have to get rid of the negative, which means we can multiply by negative x on both sides. When you do that, you have to flip the sign of the inequality, which means root 8 is greater than negative 2x, right? Now, let's divide by, again, negative 2, okay? And when you do that, okay, again, you have to flip the sign. So that means it's greater than x, right? I've divided by negative 2 on both sides, right? I have to do what I have to do to get x by itself. That's the whole key. See, you might think I went back and forth. No, I only took one extra step to get here, right? I went from here to here and then to here. Now x is all by itself and it does not include negative sign, and that's critical. And I think root 8 is 2.828 over negative 2 is greater than x, and x is greater than, this is, x is greater than negative 1.4, right? You can substitute all of these values provided in the choice and determine under which circumstance is x actually greater than negative 1.4. You can substitute negative 1, which is correct. You can substitute negative 2, incorrect, negative 3, incorrect, negative 4, incorrect. Because 1 is possible, all of the above is incorrect and all of these are incorrect. So the correct answer is A. Okay. Now, if you've gotten this far, you know, whatever I have here, this part is easy, okay? It's this part that'll be still tricky for some of you. What did I do? I multiplied by negative x on both sides, which got rid of the x from the side and took it to this other side. Again, I divided by negative 2 to get the x by itself. Your goal should always be x must appear by itself and it should not have any negative values. Okay. Solve for x. We have 3x plus 7 greater than or equal to negative 2x plus 4. Again, you don't have an absolute, so it's just a one-step process. So you can add plus 2x on both sides, which would make it 5x plus 7 greater than or equal to 4. You can add negative 4 on both sides, so that will be 5x plus 3 greater than or equal to 0. You can add negative 3 on both sides, which would make this, and then you can divide by 5 on both sides, which would make x greater than or equal to negative 3 over 5. That's the answer. This is the final problem in this video. So we have x squared minus 4 less than 0. Find the solution set for this inequality. So we have x squared minus 4 is less than 0. We have x squared, we can add plus 4 on both sides, which would make less than 4, right? It's easy, right? Whether you substitute x's, you can substitute x's. Under what circumstances is x squared is less than 4? Well, let's pick this one, okay? Right? You can pick x equals 0, but then you can also pick any one of this within this range, right? Both of these are correct. This is incorrect because minus 3 when squared, right? If you say we pick C, I'm just trying to prove my point that why it won't work. Well, how could 9 be less than 4? So that won't work. X is greater than 2. Well, if x is greater than negative 2, well, x can be greater than 2 as well because we are squaring it. This is work, but part of it is incorrect. So this is incorrect and this is incorrect. This would work because anything substituted within this range, as long as it's an integer, even if you want to choose fraction, but for a test purpose, I would just only pick an integer. So if I pick negative 1, that's less than 4. If I pick plus 1, that's also less than 4. So the correct answer is this, even though you can also do 0, which is also less than 4. But then 0 is also part of this range, so that A is the correct answer. Does that make sense? Okay. If you haven't subscribed to my channel, consider subscribing to my channel. Please stay tuned to the remainder of the videos on inequality by multiplication and division. I'll see you soon.